20-gram sample of radioactive isotope decays to 14 grams in 5 days. So we're starting with a 20-gram sample, and it decays to 14 grams, meaning we have 14 grams after 5 days. I don't even know why I'm writing it like this. If I was reading this question, I'd be making a table. I would be saying, great, at time equals 0, I have 20 grams. And 5 days later, I have 14 grams. Let's read the rest of the question. How many days will it take until there are only 2 grams left? So we're asking how much time until the amount is 2 grams. Great, we have all the information we need. Oh, and also, of course, right, since it's radioactive, since it's a radioactive materials decay exponentially, right? Any of these problems where they're talking about something, number of cells in bacteria, population, radioactive stuff, you are meant to assume that it is exponential growth or decay. Or if it's money being compounded continuously, that is also the exponential growth, right? That A equals P e to the RT. The only one you might not have it if money is being compounded, not continuously, right? If it's being compounded like daily or monthly or semi-annually, right? Then you use the compound interest formula, which will be on the front of your test. Okay, so yeah, the model, y equals c e to the kt. Your job, first and foremost, is to figure out what c and k are. C is almost always a gimme, right? C is just the value that we are starting with at time equals 0. C is going to be 20 grams. So I think you definitely don't need to show any work for finding C. You can be like, boom, I know that my model is y equals 20 e to the kt. And I used, if you wanted to, you would have used this piece of information here. Right, so now the harder job of finding out what k is. So I'm going to plug in the other data point we have. Right? I know that 5 days later, I have 14 grams. So y is going to be 14, and t is going to be 5. And then we have to solve for k. Divide by this coefficient. So 14 divided by 20 equals e to the 5k. You can leave this like that. You can reduce it to 7/10, or you can write it as a decimal of 0.7. I don't care what you do. I will say sometimes, depending on the numbers, the fraction might not be a very nice decimal. Like if your fraction is, like 2/7, you should not write that as a decimal because it's a repeating decimal, but it's like a terrible, like it's like got 6 things before it repeats. It's like 0.28145, right? Something like that. So if it's a fraction that doesn't become a decimal nicely, I would strongly recommend just leaving it as a fraction. I do like to reduce it though. So I'm going to write 7/10 equals e to the 5k. And then we're going to take the natural log of both sides. So we end up with the natural log of 7/10 equal to, we know that the natural log of e to a power is just the power. So natural log of 7/10 is 5k. And then k is going to equal the natural log of 7/10 divided by 5. We do not want to get a decimal approximation for this. We just want to leave it as it is. So then we can rewrite the model as y equal to 20 e to this gross number times t. Of course, I'm kind of out of room. Let's go ahead and erase over here. So our model now is y equal to 20 e to the k, which is the natural log of 7/10/5 times t, all in your exponents. And then the question we have to answer is, what is t when y is 20? Right, sorry, I erased my tops, right? This is the t column, so the y column. So when y is 2 grams, so when y is 2, we're going to try and solve for t. Now, here's something to keep in mind. The process for solving for t is exactly the same as the process for solving for k. Okay? They're both kind of trapped in the exponent together. right? K and T are next to each other there. So it makes sense that, oh yeah, the things we did to solve for K are going to be the same sort of things we're going to do to solve for T. I would like to erase some of this if that's okay. I am going to erase, I guess I don't really need this anymore. Okay. So same idea. Divide both sides by the coefficient here. So 2 divided by 20 equals e to the natural log of 7/10 over 5 times t. Take the natural log of both sides. By the way, 2/20 reduces to 1/10. So the natural log of 1/10 equal to, now this is where I personally don't want to write out all the stuff, right? You could write the natural log of e to the natural log of 7/10 over 5 times t. But we know that when you take the natural log of e to a power, you just get the power. So if I take the natural log, I can write it over here. We need the natural log of this, the natural log of all this. The natural log of e to a power is just the power. It's not a simple power, but it is just the stuff inside the brackets there. Natural log of 7/10 divided by 5 times t. I don't really need those brackets. I was just writing them to point out that this is the same as that. So then we solve for t. You could solve for t by just dividing by all of this, but then your answer looks kind of gnarly because you've got fractions and fractions. So I really think it's best to multiply both sides by 5. So 5 times natural log of 1/10 equals the natural log of 7/10 times t. And then divide both sides by natural log of 7/10. You can certainly do this in one step. I was just showing you in 2 steps. So t is equal to 5 times the natural log of 1/10 divided by the natural log of 7/10. And on your exam, I do ask you to give me the exact answer, meaning this expression, right? That should be one of your answers. I also ask for a decimal approximation to the nearest 1/10, I believe. So pulling out a calculator, you will need to use a calculator for a couple of the questions. Generally, you shouldn't really need a calculator for much of the test, really any of it, but I'm not going to disallow you from using a calculator. So yes, you are welcome to use a calculator for questions where you need to. I would encourage you to try not to use a calculator just since you have to show your work for everything. But that said, right, use it when appropriate. Let's see, so the natural log of 1/10 is about -2.3 times 5 is about -11.5 divided by the natural log of 7/10. You do want to do this all in the calculator, right? You don't want to approximate each step. You want to just do the whole thing. So I'm getting about 32.27, which is about 32.3 if I round to the nearest 10th days. Questions about that? So how about that? All right. Let me just move this up a little so I can see the whole chat. Let me do that as well. Cool. All right. Okay. Well, if you have any questions, you can always ask them later. Well, let's move on to the next one, which is a very similar in nature problem. You deposit $300 in a savings account with continually compounded interest. It takes 8 years for your money to triple. What is the interest rate? So we deposit $300. So we know that not our A, but our principal is $300. The interest is continually compounded. So if it's continually compounded, we know we've got A equal to P e to the RT. I'm actually going to add on to this problem just to kind of show you two things. So I'm going to answer the question for being continually compounded. I'm also going to answer for being compounded, let's say quarterly, meaning 4 times per year. So if that was the case, it would be A equal to P times 1 plus R divided by 4 to the 4 times T power, right? Where here N is 4. Okay, so back to the problem. We deposit $300 in the savings account with either continually compounded interest or quarterly compounded interest. It takes 8 years for your money to triple. So we know the amount of time is 8 years. And we know that the amount of money after 8 years should be triple, so $900. And the question is, what is the interest rate? So for any problem like this, they should be giving you essentially all the information except for the one thing that they don't give you. So if they're asking for the interest rate, they should be giving you everything else, meaning the A, the P, and the T. Or in this case, the A, the P, the T, and the N, which was 4, since it's quarterly. And then we just throw everything into the equation and try and isolate the thing we want. So if it's A equals to, I got, let's see, 900 equals 300 e to the r times 8. Since I'm trying to solve for r, I know I need to end up taking a log of both sides. After I divide both sides by 300. So 900 divided by 300 is going to be 3. 3 equals e to the 8r. Take the natural log of both sides. Or any log you want, but natural log is the one that makes the most sense. Natural log of 3 equals natural log of 8r. Sorry, that's a mistake. It's not natural log of 8r, it's natural log of e to the 8r. But the natural log of e to a power is just the power. So I've got the natural log of 3 equals 8r. So r is the natural log of 3 over 8. That's the exact answer. And then the decimal approximation, natural log of 3 is about 1.1, I think. 1.1 about, yeah. And then divide that by 8, you get about 0.137. It says, so here's an interesting question. So without rounding, I'll just round out the first like 4 digits. It says 0.1373. Okay. The question specifically says to round to the nearest 1/10 of a percent. So I'm not going to round to 0.1 because this isn't written as a percent. As a percent, this is 13.73%. So that means I should round to 13.7%. That's that number rounded to the nearest 1/10 of a percent. Not the nearest 10th, the nearest 1/10 of a percent. And if we were doing it this way, it'd be the same sort of work, just a slightly different calculation. So I'm still plugging in 900 equals 300 times 1 plus r over 4 to the 4t power. And I'm still doing the same sort of thing. So dividing by 300, so getting 3 equal to, oh, sorry, a t was what? So I looked at this, I'm like, how am I going to solve for r if I don't know what t is? Well, that means I should be able to know what t is, and t was 8 years. So 4 times 8. Wow, that's a really good looking 8 there. Sorry about that. Let me try that again. There we go, that's better. So then 3 equals 1 plus r over 4. 4 times 8 is 32, so take 32 power. Take the natural log of both sides, or whatever base you like. I'm still a fan of the natural log. Natural log of 3 equals the natural log of 1 plus r over 4. 32. Is this what I want to do? Maybe I don't want to take the natural log of both sides. So here I've done something that might not be right. Right? It's not. I didn't do anything wrong per se. It just might not be the way that actually gets us to solving for r. Because here's the problem. The thing I'm trying to solve for is now inside the natural log. But I'm trying to solve for it. It means I want to isolate it, right? I want to get r by itself, and then so I'm going to have to get it back out of the natural log. So I think taking the natural log beside is actually the wrong thing to do here. So if I'm trying to, so for continually compounded, sometimes solving the thing is different than not continually, like compounded some n times per year. So what can I do to both sides of this equation to help me get r by itself? Well, I need to get rid of this power that's not a variable. So I can just take the 32nd root of both sides. So I take the 32nd root of 3, it's equal to the 32nd root of 1 plus r over 4 to the 32nd power. But the 32nd root of something to the 32nd power is just the thing. So we get 32, the 32nd root of 3 equal to 1 plus r over 4. subtract 1, multiply both sides by 4. So r is going to equal 4 times the 32nd root of 3 minus 1. Well, that's kind of stupid. I mean, not really, but like, oh, sorry about that, Paula. Ow, foot. Okay, is that a little better?
Yes, that's better.
Yeah, so yeah, that's 4t, and then it's 4 times 8, 32, 32nd root. Yeah. If we did have to use a calculator to get this, so I would do, so instead of doing the 32nd root, although there is a root button on my calculator, I would do 3 raised to the 1 over 32 power, which is going to be 1.03 approximately, and then subtract 1. It's about 0.0349, and then multiply it by 4. So making about 0.1397. So this is approximately 0.1397, which is 13.97%. And if I was rounding to the nearest tenth of a percent, I would round it up to 14.0. Interesting. Oh yeah. The 4. So the 4 is because of the quarterly, right? So I use the formula A equals P times 1 plus R over N to the NT power, but I just plugged in 4 for N since it is quarterly. Right, so it's meaning once every 3 months. Exactly. Right, so if it was quarterly, it's once every 3 months, so 4 times per year. If it's monthly, it's 12 times per year. If it's daily, it's 365 times per year. Right, that's weekly, it's 52 times per year. Right, that's the whole idea. Ow, I kind of hit myself a little too hard there. Okay, let's look at the last couple questions on here. Find the point on the line, y equal to x plus 3. Oh, I just realized. I did say I was going to post these solutions, and I didn't post them. I'm sorry. I will post them. I do have them right here. I just have to take all the pictures and scan them in. So I will actually post the solutions. Apologies for not having done that sooner. I know I said I would do it yesterday. Totally slipped my mind. So I'll get the solutions of these posted up. Let's go and look at the last couple questions here. So let's see, we have find the point on the line, y equal to x plus 3, closest to the point on this line closest to 6,3. You don't have to draw a picture, but I find it helpful to draw a picture. So the line y equals x plus 3 has a y-intercept of 3 and an x-intercept of negative 3. And the point 6,3 is like over here. And so I'm trying to find the unknown point on the line where we don't know what it is yet, but there's some point on this line that is closest to that point there. I don't know this point, so I'm going to call it xy. And our job here, well, right, the hint is you have to minimize something. To find the closest point, we have to minimize the distance between them. This is problem 18 on the exam one. So we're going to minimize the distance, which is the square root of x minus 6 squared plus y minus 3 squared. Okay. So whenever we want to minimize a thing, we need to have a function of one variable. So we really need to be a parabola. And the issue here, well, there's two issues really. One, we have x and y. We need just x or just y. So we need a constraint. The constraint is that the point is on the line. So our constraint is actually kind of already given to us. It's just that y equals x plus 3. So we can put that in here. So now my distance is going to be the square root of x minus 6 squared plus x plus 3 minus 3 squared. I can cancel the 3's. And let's multiply this out a little bit. This is going to be the square root of x squared minus 12x plus 36 plus x squared. Now here's kind of the key thing you have to remember for this particular problem. Instead of minimizing the distance, it is equally valid to minimize the square of the distance. So we're going to say, oh, look, I can minimize the distance squared. And the distance squared is just the same thing without the square root. So it's going to be x squared plus x squared, which is 2x squared minus 12x plus 36. If I want to minimize this, I want to find the x value that makes it the smallest. Well, I need to find the x coordinate of the vertex. That's going to be negative 12 over 2 times 2. That's going to be 12 over 4, which is 3. So that means the x coordinate of the point on the line is 3.
Well, where did you get the 2x squared? Oh, the 2 from the 2x squared. Oh, okay. Thank you.
You're welcome, of course. So the x coordinate is 3. So we have to be really, really careful finding the y coordinate. We're not going to find the y coordinate by plugging y into this parabola here. This parabola tells you what the distance is when you know what x is. So if x is 3, the distance is whatever this is equal to. Or if x is 3, the distance squared is whatever this is. So in fact, if you did plug it in, not that we should, but if you plugged in x equal to 3 here, the y coordinate or the distance squared coordinate of your vertex would be 2 times 3 squared, which is 18, minus 12 times 3, plus 12 times plus 36. So I want to point out 18 is not the y coordinate, it's the square of the distance of the closest point. The y coordinate we get by just using the constraint. If x is 3, y is going to be 3 plus 3, which is 6. So our closest point is 3 comma 6. And that's it.
Can I ask a question?
Of course.
I'm a little confused about the step after you found the vertex.
So this step, so you're cool with this?
Yeah, and I'm cool with the second part where you got.
So the second part that I didn't actually need to do. This part here is totally unnecessary. Because the question asked, what point is closest? It didn't ask what the minimum distance was. So this distance here between these 2 points is the square root of 18. Right? Because the distance squared is 18. But the question asked for what point is closest. So once I found the x value, I'm like, okay, well, I know the x value is actually the x value of this point. But the y value, I'm not getting from the parabola because the parabola is representing the square of the distance. I'm getting the y coordinate by going back to saying, oh, well, I know that this point is on this line. And if I know that x equals 3, then y has to be 3 plus 3, which is 6.
Okay, thank you.
Most of the time, when a question asks you for the dimensions or the numbers or the whatevers that maximize the thing, but not for the actual maximum value, which is usually how these questions are phrased, you find the x coordinate of your vertex, and that's one of your things. And then you find the other thing, not by finding the y coordinate of the vertex or the second coordinate of the vertex, but by going back to your constraint and plugging in your known value to find the other value. That's usually the method. All right, let's look at the next question. So let's see. This is the extra credit question. A zookeeper wants to build a single rectangular enclosure for the lions. One of the walls needs to be stronger because it is the side that separates the lions from the people. That's important. Than the other three sides. So we've got a rectangular enclosure. And one of these sides needs to be stronger than the other three. So let's say this is the stronger side. So make it like extra strong. Now, here's where we have to be careful. I'm trying to figure out, so actually, let's read the rest of the question. The strong side costs $20 per foot, and the other sides cost $10 per foot. If the zoo has a budget of $6,000, what should the dimensions be to maximize the area? So I'm trying to find what are the dimensions. And I'm trying to maximize the area. So I'm just going to label the dimensions X and Y. I know that this side costs more than the other sides, but I'm not going to write that cost on my picture because I'm just trying to write down how long these things are. So to maximize the area, well, the equation for area is just X times Y. But then I need a constraint, and the constraint is my budget. So my budget is $6,000. And I know that these three sides all cost $10 per foot. So if this side was, say, 20 feet long, it would cost $10 per foot times 20, which is 200. But it's not, it's X feet long. So this side costs 10X. Paul, this is number 19. It's the last one on the practice test. So this side is 10X dollars of cost. This side is going to be 10Y dollars of cost. This is going to be 10X again. But this side, since it's $20 per foot, it's going to be 20 times Y. So there's our constraint. So we've got, simplifying a little bit, 6,000 equals, let's see, 10X plus 10X is 20X. 10Y plus 20Y is 30Y. And then we're going to isolate one of these variables. I don't really care which one, but you might. You might prefer to isolate Y here so that you can plug in for Y and have your thing in terms of X. That might just feel more natural to everybody. But you should do whatever you like. So I'm going to divide everything by 10 to make life a little easier. So 600 equals 2X plus 3Y. And I'm going to solve for Y. So 600 minus 2X equals 3Y. Y equals 600 divided by 3 is 200 minus 2/3 X. That's what's going to go in for Y here. So my new area equation is going to be X times 200 minus 2/3 X. Let's multiply it out. So the area is 200X minus 2/3 X squared. Or if you prefer to write it in the standard order, you could write it as negative 2/3 X squared plus 200X. Let's find the X coordinate of the vertex. I really should say the first. So like if you used Y's here instead, you'd still be finding the first coordinate of the vertex. It's just going to be your Y value instead of your X value. So let's see, it's going to be negative 200 over 2 times negative 2/3. Right, negative B over 2A. So that's looking kind of terrible. It's negative 200 divided by negative 4/3. When you divide by a fraction, you flip and multiply. That's going to be, let's get rid of the minus signs as well. 200 times 3/4. 200 divided by 4 is 50. 50 times 3 is 150. Or you could just say 3/4 of 200 is 150. So we're getting X equal to 150. And now I'm going to point out the same sort of thing I pointed out last time. If I plug this back in to find the Y coordinate of the vertex, I'm not going to get the Y value here, right? If you plug in 150 back into this equation here, you're going to get that area is something kind of gnarly, right? Negative 2/3 times 150 squared minus, plus 200 times 150, which ends up being, I can do the math there. Sorry, 1 sec. 100, I think it ends up being 15,000. I'm not going to worry too much about it, but that's definitely not how long the Y side is, right? It doesn't make sense that this side's 150 feet and this side's 15,000 feet. That seems ridiculous. Also, way over budget, right? This was 15,000 and it costs $10 or $20 per foot. That would be way more than $6,000 a budget, right? So this Y coordinate of the vertex is your maximum value of the thing you're trying to maximize. That's your maximum area, which we weren't asked to find. Nobody said in this problem, find the maximum area. They said, find the dimensions that maximize the area. So the other thing we need is Y. So, I know X is 150. So Y is going to be 200 minus 2/3 times 150. 2/3 of 150 is 100. So Y is going to be 200 minus 100, which is 100. You might notice that my rectangle looks like I've drawn it wrong. It's because I did, right? The shorter side should have been the side with the strong fence. That's okay. Your picture doesn't have to look exactly like the answer is. It's just a representation of what we want so that we can write down the equations. So don't worry about your picture not looking to scale or looking like the long side really the short side, vice versa. It doesn't matter. Paula, yeah.
Wouldn't we also, since we already have area anyway, we just plug it back and we also have the X value into the formula for area? So like that's 15,000 equals 150 times Y and you still get 100.
Totally. But to be perfectly honest, the way I found the area was by knowing that Y was 100. Right? I actually didn't really do this calculation. What I really did was I looked here and I said, oh yeah, when I plug in X, I get 150 for X. I get 200 minus 2/3 of 150, which is 100 for Y. And then I did the multiplication. But you're totally right. If you happen for some reason to be able to get this easily, you could totally work backwards to get your Y value. I don't think that's the best way to do it. Right? It's definitely better to just say, oh yeah, here's an equation for the thing I actually want. Let's use that. But you're not wrong. You could totally do it that way. That would also be correct.
Thank you.
You're welcome. All right, so that is all of the exam 1 from fall 2020, which again, I will post the solutions to after we're done with class today. Did anyone have any specific questions from the review that I posted that you might want me to go over?
A review for the midterm 1?
Yeah. I see one question I want, so I'm going to pick one. If you guys have one, you're certainly welcome to let me know. But I see one that I definitely want to do that we have that wasn't on this practice test, but I definitely wrote a question like this on your exam. So the exam is very similar. It's not exactly the same as the practice test, but very, very similar. Well, let's look at this question 11 from the midterm 1 review problems. So the question is log base 3 of 13 minus 7x minus log base 3 of x plus 5 equal to 2. So if I'm trying to solve a logarithmic equation like this where I have more than one logarithm, usually the first thing is to compress those logs together. Since it's subtraction, we're going to rewrite this as log base 3 of 13 minus 7x divided by x plus 5 equal to 2. And then we're going to rewrite this equation as an exponential equation. So instead of writing as log base 3 of this stuff equal to 2, we're going to say 3 squared equals the stuff inside the logarithm. 13 minus 7x over x plus 5. 3 squared is 9. And I'm going to multiply. It's usually the best step is to next to get rid of the denominator. So I'm going to multiply both sides by x plus 5. So I'm going to get 9 on the left times x plus 5 equal to 13 minus 7x You can show this work of saying divided by x plus 5 times x plus 5, and then those cancel. Or you could just say, I know it's 13 minus 7x. Multiplying out the left, you get 9x plus 45 equal to 13 minus 7x. I would probably add 7x over here to get 16x. I would subtract 45. 13 minus 45 is negative 32. And then I would divide by 16. Negative 32 divided by 16 is negative 2. So x equals negative 2. And then I need to check and make sure that it's not extraneous. So I plug in negative 2 here. That's okay. Negative 2 plus 5 is positive. I plug in negative 2 here. That's okay. 13 minus 7 times negative 2 is 13 plus 14, which is definitely positive. So negative 2 checks out. But you do need, for these logarithmic equations, you do have to check that any of your solutions are actually valid and not extraneous. So, and there will be, I will guarantee you that there is one equation at least on your test where there is one extraneous solution for sure. So definitely do check.
So if that's the case, we just highlight or let it be known that we haven't.
Yeah, so let's say there were two solutions. Like let's say we got x equals negative 2, and we also got like I don't know, let's say x equal to 4. So I'd be like, okay, x equals 2 is cool. Negative 2, sorry. And if I plug in 4, 13 minus 7 times 4 is 13 minus 28, which is negative. Oh, I can't take a log of a negative, so I just cross that one out. I do want you to find the extraneous solution and then tell me that it's extraneous. Which you kind of can't help it when you're doing these problems. Ooh, that's good.
Is like the circles part of the first midterm? Because like finding the equation of the line that intersects the circles, can we go over that one? It was like in a homework, I think.
The equation of the line that intersects the circles?
That joins the centers of the circles.
Oh, sure, yeah. Okay, I'll just make something up. So let's say we have these two circles, x minus 5 squared plus y plus 2 squared equal to 11, and another circle, x squared plus 6x plus 9. Plus 9, James, come on. X squared plus 6x plus y squared minus 10y equal to 1. So those are two circles, and just like Paula said, I want to find the equation of the line that goes through the centers of the circles. So, right, you got this circle here, you got this circle here, you got their centers, and our job is to find the equation of the line that goes through those two centers. So to find the equation of the line, you need a point. We will have a point, and you need a slope, which we'll have to find. So this circle is easy. Its center is 5, negative 2. This center requires more work, or this circle requires more work to find the center, but to complete the square. So for this one, I'm going to have, let's see, x squared plus 6x plus 9 will complete the square here. And then y squared minus 10y plus 25 will complete the square there. If I add it on the left, I have to add it on the right. That's going to equal 1 plus 9 plus 25, which I'm just going to say is 35 because I'm kind of out of room over here. Right, that's 1 plus 9 plus 25. And then this is x plus 3 squared. This is y minus 5 squared. So our center is negative 3, positive 5. Notice we don't care at all what the radiuses of either of these circles are because we're not concerned about that. But here the radius would be the square root of 11, and there the radius would be the square root of 35. And that's just it, right? There's no simplifying that. So then the equation, we have to find the slope. So the slope between 2 points is the difference in the y's over the difference in the x's. So 5 minus minus 2, right? 5 minus minus 2, and then negative 3 minus 5. That's going to be 7 over negative 8, which is negative 7/8. So then to find the equation of the line, we say y equals mx plus b. And we plug in either point we want. I'm going to pick, I don't know, the first one. I'm going to plug in negative 2 for y and 5 for x. So I get negative 2 equal to negative 7/8 times 5 plus b. Okay, this is where things get a little bit gnarly. Negative 7/8 times 5 is negative 35/8. So I have negative 2 equal to negative 35/8 plus b. I'm going to add 35/8 to both sides. So I'm also going to change negative 2 to be in terms of eighths. So negative 2 times 8 over 8 is negative 16/8. I'm going to add 35/8, and that's equal to b. So negative 16 plus 35 is going to be 19. So 19 over 8 is equal to b, which means the equation of our line is then y equal to negative 7/8 x plus 19/8. That's how we do that.
Could we also plug it in as I think it's like y minus y1?
Totally, yes.
Okay.
Either way is perfectly fine.
And for that, we would use the x and y in between the parentheses, right?
Sorry, say that one more time.
Like we'd use the values of 5 and negative 2 and also negative 3 and 5.
Well, either one. You don't use both though.
Okay.
Right, so if you do it the other way, if you do it using the point slope form, which is the y minus y1 equals your slope times x minus x1, you're going to say y minus, pick either one. I'm going to pick this one. So y minus minus 2 equals your slope, which is negative 7/8 times x minus 5. That's also perfectly fine.